Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. The channel, what we are discussing, this channel is all about the construction, quality control, and success of quality control engineer, how they become successful in their career. So, today, what I will discuss? Today, I will discuss about important topics on the construction. All we are talking about the concrete technology, concrete, but the base material is cement. So there are different types of cement available in the market. Now, how you can select the right kind of cement for your construction or for your projects. So although there are different types of cement, but we have some criteria. On that basis we can select the cement for our construction. So stay tuned until then to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. If we are thinking about the cement, what first thing is OPC, ordinary Portland cement, but it is not the end. So OPC has their different grade. 33, 43, 53, 53S, 43S. Not only OPC3, and then we have PPC, PSC, SRC. So there are different cement is there. That although they have the rapid hardening cement, but why this all that is cement? And now, as an engineer, when you are want to select cement for your concrete, what cement should you use? That question is come to your mind. But there are some basic criteria that you have to remember whenever you are selecting your concrete or cement for your concrete. So first is the factor is structural requirement. Now, what is the cement used? Cement used to making the concrete. Now, concrete is very much good in compression, but not in the tensile. But any component has the compression load as well as the tension load. So withstand the tension load, we introduce the reinforcement that we call the RCC. So structural requirement, compression as well as tensile. So what we can consider for the constructional part, what is the load on the structure? See, in the beam load pattern and the column load pattern are not the same. Slab load pattern and the beam load pattern is not the same. There are different load pattern. So what is the load on the structure that we need to discuss? And the same beam is not same for everyone. If the beam is cantilever, if the beam is simply supported, if the beam is one way supported and one is fixed, so the loading pattern will be the different. And also what is the loading is coming, if they have the point load or the distribution load, according to that load pattern is separate. So you need to design, or you need to find out that member, maybe the column, maybe the beam, maybe the uh, slab. So what are the loads coming, whether it's a mainly compression load, there's a column is coming compression load. So accordingly what is the criteria, and according the criteria you have to select your cement. Then crack width, if the crack is generated, how crack width is there. So in the crack width, because it is define the characteristics of the load stability. Then deflection, this is the main criteria. What is the deflection? Although it is a part of design, we are not looking after because we are working on the site as an engineer, so we think that it is not our part. But as an engineer, you know what is the deflection. So what is the deflection criteria, or you know how the deflection will affect the our loading pattern or our affect our structural stability, that you have to keep in mind. Another thing is the creep. All we know, the creep is the uh, long time deformation or time dependent deformation under a sustained load on the structure. So this creep coefficient as well as the shrinkage coefficient, that is also defining the load on the structure. So according to the load on the structure, you have to design what is the strength criteria for the concrete, and according to the strength criteria you have to propose your cement. If the concrete strength is high, you have to propose the high compressive strength cement, maybe the OPC 43 or OPC 53. If it is low, you can go for the OPC 43 or OPC 33. So you need to find out what is the loading pattern or what is the loading criteria and what is the load. That is a structural requirement. For the first things it has to be kept in mind that we need to find out what is the structural requirement and what is the structural pattern or the load pattern of the structure. So this is the first criteria. Second is the functional requirement. Now, what is the functional requirement? See, every concrete we are using, it's not withstand with the same purpose, right? We are using in the building, we are using in the factories or the warehouses, we are in the marine structure, we are in the water retaining structure. Although we are doing the concrete, but they are exposing in some different environment. So the functional requirement also have the different criteria. So the functional requirements, some think you need some areas early strength you need. So why? All you know that when you are adding water, the cement and water start reacting, and this reaction giving the CSH gel, and they are forming, and it's giving the strength. So the strength criteria in 7 days we are getting 70% as is the minimum criteria, and 28 days we are getting the 100% strength. But again, it is dependent what are the cement criteria and what is the supplementary cementitious material you are using, or what is the, your mixed design. But if you need the early strength, because you, if you want to remove the dish shuttering, or if you want to do the next course of action, so what is the strength gain criteria that has to define. So if you have the strength gain criteria or the early strength, that should be OPC 53 or OPC 53S is the option. Then if it is a normal strength, then you can go for the PPC, PSC, whatever, or OPC 33 gauge. But in the industrial area, what we are discussing, so industrial area means it has some other environmental category than the normal one. So it has exposed to the industrial waste and industrial category. So here mainly is the sulfate. So sulfate resistant cement or the SRC cement, you have to use that one. Although you have to design, then you have to select. In the mass concrete, what is the mass concrete criteria? Mass concrete criteria is that it should be low heat of hydrogen. Why? If the heat of hydrogen is more in the local mass concrete, then there will be a temperature gradient, or the core temperature will be more than 70 degrees centigrade, or the temperature difference or the temperature gradients will be more than 20 degrees centigrade. So what will happen? The cracks will generate, that is the thermal crack. So what do we need? We need low heat of hydration. So who is mainly responsible for the heat of hydration for the first 7 days is the C3S, because it start reacting immediately with the water, and it is the exothermic reaction, it's producing heat. So if we have the cement is low C3S, then the reaction rate will be less, and the heat of hydration will be less, heat generation will be less. So keeping in this mind, you have to select for the mass concrete low C3S. Not only low C3S, we have to use the supplementary cementitious material, ice flakes. There are other criteria for the mass concrete. I have made a detailed video on that. Link is the description, you can check, you will find out all the details. So if mass concrete, go for the low C3S concrete. Then blast furnace or the chimneys, where it is hitting with too much heat. So the normal concrete, if you are using the CS gel, it is forming, that will disintegrate with the high heat, so it will lose its strength. So we need to replace with the ordinary cement, go for the refractory cement or the high heat strength gain, or carrying cement. So what is that? It will not disintegrate if with the hot or the heat, because it is not forming the CS gel, it is forming the aluminum gel. So that is not disintegrate with the heat. So if it is your criteria, it's blast furnace or the chimneys, go for the refractory cement. So this is the functional requirement, and according to the functional requirement, you have to select your cement. The next is coming is the type of structure. It is also important. See, I'll discuss the building, factory, warehouse, water retaining structure, marine works, road, bridges, flyover. Now, if it is a normal building, whatever normal OPC or F33, 43, you can go. But if it's a factory or warehouse, so there may be chances other chemical is there. So we have to go for the PSC or the SRC. And water retaining structure, something it is retain the water. So it will be hydrophobic cement maybe, or you have to use the supplementary cement material to make the concrete dense. Then the marine works, there's a chloridism problem. So you need to act accordingly. Then road, bridge, and flyover also, the carbon dioxide is a problem because it's mainly in the city. So accordingly, you have to choose what type of cement you need to use for the different types of structure. Then this coming speed of construction. Now, in this age, we are making our concrete more faster. We need 7 days a life cycle for the slab. That is normal in throughout the industry. Within 7 days, we have to do the next bore. So what the criteria? Criteria, you need to rapid strength gain. So that's why you need to go for the rapid hardening cement or high C3S cement or OPC 53 or OPC 53 grades. And then repair and rehabilitation work. Now where we need mainly roads, bridge and flyover, and we cannot close that area for prolonged times. So we need immediate strength gain. For that area also we need the Kong cement, which has given the early strengthen criteria. And precast and prefab factories, that is also, see, if you are keeping your precast element for the long time, the next batch of the casting will be delayed and your production will be less. So that is not the acceptance criteria. So that is why you need to use the concrete cement who is giving the more strength or the early strength, maybe the high strength early strength gain concrete or rapid hardening cement. So these are all the criteria you have to keep in your mind whenever you are dealing with the cement or whenever you are selecting the cement. Then it is a coming in the soil condition. Now why I am talking this? Because in the soil there are different types of chemicals there, like sulfate, chloride, magnesium. These are all is there. Now if it is penetrated inside the concrete, it will start reacting with the concrete, as well as it will start reacting with the reinforcement. So corrosion of reinforcement will happen and disintegrate of the concrete will happen. Concrete cracks, falling, that sand can be happen. So what you need to do, you need to analyze what is the soil condition, what is the sulfate content, what is the chloride content of the soil. So you, according to that, whenever you know that what is the sulfate content and what is the chloride content, and accordingly you need to work that this is my maximum cement chloride content. So what type of cement we can use? So that may be the SRC, that is sulfate resistant cement, or the Portland slag cement. What is happening? That is, it is repelling the sulfating effect or the sulfate attack. And why? Because you need to know what is the exposure condition. I will come later that one. But in the soil, the sulfate ion, chloride ion is there. So you need to protect from your structure from that effect. So here you can go for the SRC and the PSC. But again, this is the general guidelines, but not the ultimate. You need to check every parameter and accordingly you have to select the cement. But keep in your mind, these are the criteria. Then durability of concrete, this is the concrete exposure condition or the environmental condition. Now what is happening? We are making concrete and it is exposed to the water weather. Now there is a rain, there is a winter, there's too much hot, there is a other chemical like sulfate, chloride, carbon dioxide, all is there. So how this will react with the environment, that is the concrete durability. Because we are not making concrete for 1 day, 2 day or 1 year. It is a long lasting 100 years. So we need to protect our concrete from the adverse condition of the environment. So the concrete exposure condition is very much important. So according to the concrete exposure in condition, you need to play your concrete. Suppose you are not giving the that much of concern about the concrete, and you are doing a area where sulfate content is more and you are not using a certain cement. So what will happen? It will penetrate the sulfate ion inside the concrete and it will form the tringite and it will crack the concrete. Now if the crack is the concrete strength will be a problem. Then the durability, because with the crack itself, again moisture, carbon dioxide, chloride and other chemicals will penetrate, and other ions will penetrate. Again it will start reacting with the cement and the concrete and the reinforcement, and again it will be disintegrate the concrete. So durability is also a pattern, and accordingly you need to find out what is the concrete exposure condition. In IS 456 is given the 5 categories. So according to the which category your project is playing and what the exposure condition of your concrete that you have to measure. So these are the criteria. There's structural requirement, functional requirement, type of structure, speed of construction, soil condition, and durability of concrete, and the exposure condition. So accordingly, you have to select your concrete. How? You have to one by one write it down where you are doing the concrete. It is not any hard and fast rule for that for if you want to do this you use this cement. No, mixed design is has open areas and open space. You can play on that area, but if you want to play on the mixed design, you have to know the science behind it, and you have to know why I'm using this cement, why I am using this cement, why I'm using supplementary cementatious material. All these things you need to know. So when now in next time if you want to select what kind of cement good for your concrete, don't follow blindly anything. One by one write it down all this criteria, and accordingly you select your concrete. And I hope you can find out your best cement for your concrete. And if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video you will get immediate notification. And without wasting time, I'm waiting for your valuable comment, so that from your valuable comment everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.